All right, so as we start our look at trigonometry, we want to first of all set the context of what we're going to be doing a lot of our things in, and that is angles on the coordinate plane. Okay? And what we have here is we have what's called an angle in standard position. You guys know that an angle has a vertex. All right, and then it has two sides, okay, usually as rays, or by definition those would be rays. But the vertex, when we have an angle in standard position, is always going to be on the origin, okay? The initial side, here meaning starting side, or beginning side, is always going to be the positive x-axis, okay? And then we're going to rotate from there either counterclockwise or clockwise. All right? For those of you not familiar with those terms, clockwise means in the same direction a clock would rotate. Counterclockwise means the opposite. Okay? Yes?
Then there wouldn't actually. So then why are there two rays if there's only one that rotates? Is it just showing the beginning and end?
Yeah, the one, it's always going to start here on the positive x-axis, and then we're going to measure going this way. Okay? Now, one thing that you haven't worked with before is the concept of a negative angle. All right? Here in trig, we are able to work with negative angles because the negative, it's kind of like vectors. The negative is indicative of direction. Okay? The direction, if we have a positive angle, we're rotating counterclockwise. If it's easy to remember because you start going up from the positive x-axis, rotating up. So that's a positive angle. If I rotate down or clockwise from that positive x-axis, that's going to give me a negative angle. Okay? So, for example, in this case, I might measure this angle and get, say, 120 degrees. Okay? That's this angle right here. However, if I were to measure this angle down here, in a geometry class where we're just measuring them regardless of the unit circle or anything, we might say that that's like 50 degrees or something like that. But because we rotated down, we rotated clockwise, we would say that has a measure of negative 50 degrees, or whatever that is. Okay? Everyone with me so far?
Yes.
All right. Now, another term here that you need to be familiar with is the idea of coterminal angles. Coterminal. If you break this down, if you break down the word and understand what the term is saying, it's easy to remember, okay? Co is a prefix meaning what? What? Okay, together, what'd you guys say? Along, adjoining, okay? This idea of co, if you have like co-workers, they're people who work together. Or with, yes. Okay? So, I'm going to use the word together because that'll kind of fit our definition best. All right? Together. And you can see the root word here. What's the root word? Terminate. Okay? Our root word here is terminate. If you terminate something, you do what to it? Destroy. If you're the terminator. Okay? It means to end. Okay, if something terminates, it ends. If you do in computer science, you might have a function that you've called and you want it to terminate at a certain point. Okay? It ends. Notice here, we called this side here the terminal side. It's the side where the angle ends. All right? So, these coterminal angles are angles that end together. Okay? You might say, well, wouldn't that just make it exactly the same angle? The reality is no. Okay? Because we have a rotation that's going on here. Okay? You'll notice here in the diagram I gave you, we have angle alpha and angle beta. By the way, in trig, you're going to see Greek letters a lot. If you see a weird symbol, it's just angle. Don't worry if you don't recognize what Greek letter it is. Okay? It's an angle. So here we have alpha, and it's is that a positive or negative angle?
Positive.
It's positive, okay? So this might be, say, like 210 degrees or something like that.
I think it's 227.
Okay? This other angle here, beta, is rotating the opposite direction. Now, if that's 210, notice these two angles together make up how many degrees? 360, a full circle. So if alpha is 210, what would beta have to equal?
150.
Yeah,
Negative.
and we would say, good, negative 150 degrees. So we would say 210 degrees and negative 150 degrees are coterminal angles. Because if they're in standard position, they're going to end in the same spot. Okay? Now, there's another way we can get coterminal angles, because the reality is there's actually an infinite number of coterminal angles right here. And that's because, what if we rotated a full circle and then went there? Okay? That would be a full 360 degrees plus another 210. So 360 plus 210 would be 570 degrees. Okay? So 570 degrees would be a coterminal angle to 210 or to a negative 150. And you guys can kind of see how we would have an infinite number of possibilities. Because what if I rotated around twice? Or what if I rotated backwards a full loop and then went negative 150? Okay? We could keep rotating as many times as we wanted, and that gives us an infinite number of possibilities. Okay? In fact, one thing that we would say, we could express all the angles that are coterminal to 210 using this expression here. We could say we have 210 plus 360 times n, okay, where n is an element of the integers. N is any integer. So if n was negative 1, we'd have 210 minus 360, that gives us our negative 150. If we had n equal positive 1, we'd have 210 plus 360, that would be 570. Okay? And so on. In fact, when we solve equations later, we can give answers like this. Okay? But here, the key is that you understand what coterminal angles are to start here. Okay? Now, another thing that we need to look at with angles, we're kind of hitting a little bit of a hodgepodge of topics here on the first day, because we have a few terms that we need to make sure that we understand before we can really do a whole lot with stuff. Degrees, minutes, and seconds. Okay? Minutes and seconds are one way that you can express the decimal measure of an angle, or the decimal portion of an angle. For example, if I had, say, 35.27 degrees, I could express the 0.27 part in minutes and seconds. All right, where do we see this in real life? Longitude and latitude. Okay, if you do anything that ever involves navigation, okay, you're going to deal with the latitude and longitude, and those minutes and seconds things are just angle measurements. Okay, we'll look at that here in a second. But one thing I want you guys to notice is that the minutes and seconds, just like minutes and seconds when it refers to time, are out of 60. Okay? So I want to look at converting here a little bit. A common abbreviation for degrees, minutes, and seconds is DMS. Okay? And DD stands for degrees with decimals. Alright? So we can convert, in this case, from degrees, minutes, and seconds to degrees with decimals if we remember that how many seconds are in a minute? 60. Okay? So instead of 38 degrees, 42 minutes, and 50 seconds, I could rewrite this as 38 degrees and 42 and 50 60ths minutes. Right? Because they're 50, I have 50 out of a full 60 seconds. Okay?
I got it.
Now, how many minutes are in an hour? 60. Alright?
Oh my god, Terry.
Okay.
I thought it was like one of those trick questions.
No trick questions, alright? So if there's 60 minutes an hour, how many minutes do you think are in a degree? 60. Okay? So guess what? You take whatever you get there, the 42 points, I believe that's 8, 6, 6, 6, 6, 6, 6, 6, and so on. Alright? And then you put that out of 60. So I would have 38, and it's like 42.66 repeating. You put that over 60.
Fantastic.
And that'll give you your value in degrees. Alright, so that is not 0.66666, it's 0.833333. I was thinking it was 16 2/3% is 1/6. So, alright, so 38, and you would have 42.8333 out of 60. Okay, so now you divide that. Oop, I needed to add the
Degrees.
okay.
Degrees.
I need to divide that by 60, and I get here 38.7138 or and so on degrees. Okay? So we could round that, if we rounded that to 2 decimals, it would be 38.71 degrees.
Degrees.
Okay? Does that make sense? So those are our degrees with decimals. Now, we can also convert going the opposite way. If I have 16.811 degrees, I know that that is going to be 16 degrees, but now I need to figure out how many minutes it is.
So you divide by
111.
You multiply by 60.
Multiply by 60, okay? So I do the 0.811 times 60. 0.811 times 60. That is 48.66. So how many minutes do I have?
60.
48.
What?
How many minutes do I have for this angle?
49.
48.
Wait, what?
We're not going to round yet.
Yeah, but
Because we don't just have minutes, we also have seconds.
yeah, that's what isn't it 66 seconds? Or that's 0.66 out of 100?
It's 0.66 out of
60.
60.
Yeah, so you would have 49.
Okay, so 0.66 times 60 would be 39.6 seconds. Okay,
Yeah.
so notice here,
I just realized that too. That you're like putting it over 60 still.
And guys, for the seconds you can round, okay? So we would make that 40 seconds, all right? So this is 39.6, all right? So we round that to 40 seconds, okay? So guys, this was our minutes. So I took the 48 minutes, and then I took the 0.66, and I've got to figure that out as seconds. Because I have 0.66 of a full minute. So how many seconds would that be?
40.
All right, it's about 40 seconds. Okay?
Wait, don't those dashes mean the same as like feet?
Yeah.
There's some repeated notation here, yeah. In this context, though, we're talking about minutes and seconds.
I'm sorry, wait, which one's feet and which one's inches?
One is feet.
One is feet, is 2 inches, okay.
So where is this used? I want to show you just how this latitude and longitude works, okay? And this is just kind of so you guys can see it, all right? This is how our globe is set up, all right? The latitude goes side to side, all right? If you think on your muscles, if you know your anatomy, these are your latissimus dorsi muscles on the sides of your rib cage. Okay, your lats. All right, latitude goes side to side. All right, the equator is 0. The equator is 0. So from the center of the Earth, we're measuring where the initial side is along the equator, and then we measure up to the surface of the Earth, and in this case, that's a 30-degree angle. So this is 30 degrees north longitude, or latitude, sorry. Okay? Notice how it's kind of like our standard position. If I were to measure down, okay, I measure down 60 degrees, okay, that's 60 degrees south latitude.
Why not negative?
Okay? You can, and actually, when we find distances and things like that, we would treat south as like a negative. Like if we wanted to find the distance between somewhere in the northern hemisphere and somewhere in the southern hemisphere, we would treat the southern hemisphere latitude as a negative.
What about this word student like east and west? Are you like doing negative and positive with that too? Or?
You can treat it that way. It's a little different because we're looking at it from the top. Okay? Our longitude, okay, is from top to bottom. All right? So longitude, we have what's called the prime meridian. It goes through Greenwich, England, which is like right there. Okay? Here, if we rotate to the right, okay, that's going to the east. That's like a positive angle. And if we rotate to the left, we're going to the west, so those are the negative angles, okay? So like here we have a negative 45 degrees, or in other words, 45 degrees west longitude. Or here we rotated to the right, so that would be 30 degrees east longitude, okay?
Would the 0 be on the center of the Earth? The Earth, or like in the
No,
center of Africa?
this is where latitude and longitude are a little different. This is where latitude and longitude are different. Latitude is an angle from like the core of the Earth, the center of the Earth, measured out to the surface. Here, where you're measuring from is like the North and South Pole. And the reason why it's different, or I guess that difference is why, notice all the latitude and longitude, all the longitudinal lines intersect at the North Pole and the South Pole. The latitude lines are all parallel to each other.
Yeah.
So that's why they're different, because the angles are actually measured a little bit differently. Okay? So that's one application. We will be working a little bit with navigation. So if you're a little shaky on your north, south, east, west, you need to review it a little bit. Okay? North, south, east, west, or never eat soggy waffles. Okay?
Well, so we just say worms.
Well, I wouldn't want to eat those either, so that'll work.
Never eaten salty.
Okay? All right. Now, I want to just define the concept of the radian. The radian is something you guys haven't worked with before, okay?
On the SAT.
But it is something that you will work with a whole lot, okay? So you've got to understand this. And this is where we'll end up today. A degree, 1 degree, is 1/360th of a full circle, or a full rotation. Okay, so if you have your circle, let me put a circle in here. Okay. Let's make it so we can actually see. Alright, so let's see. If this is the center of the circle, 1/360th of a full circle. So, really, really small. Okay. We're only going 1/360th of the way around. Now, a radian is also defined based on how much of a rotation it is, but it's defined a little differently. This is kind of interesting. A radian is defined as the angle, okay, the angle that it takes to rotate so that the distance you've traveled along the circle is equal to your radius. Okay? Now obviously this distance along the circle is an arc. Okay, we actually call that arc length, and we'll be working with arc length later on here. Okay? But that arc length is the same as the radius of the circle. Okay? Now, the arc is not the radian. The radian is the measure of the angle. Okay? And there's a couple things that you need to know about radian that we'll do more with tomorrow when we look at actually converting from degrees to radians and back and forth. But a full circle is 2 pi radians. Okay? Do not put the degree symbol when you're talking about radians. Alright? We just call them radians. They're not 2 pi degrees radians. That doesn't make any sense. Alright? So 2 pi radians is a complete circle. Alright? Which means half of a circle would be 1 pi. Okay? So pi okay, that's going to be a semicircle. Alright? So, if I'm looking at it in standard position, notice that's what I would see. Okay? From the positive x-axis all the way rotated to the negative x-axis is pi radians, which is the same as how many degrees? 180 degrees. That right there is an identity that you need to become very familiar with. Pi is 180 degrees. We'll use that tomorrow.
Wait, do you mean pi r? So 180 degrees.
Pi radians is 180 degrees. And remember, pi is 3.14, okay? So it's pi is not a label or something here. It actually is the value. 3.14159 blah 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 radians is 180 degrees. Just like 3 feet is 1 yard, okay? 128 ounces is 1 gallon, alright? It's just simply a conversion here. 180 degrees is pi radians, okay? that make sense?
Like a radian's like around high 50 degrees.